Hey, good morning, guys. So yesterday's video didn't work, so I was going to make another one. That's why I'm not wearing my mask, because I'm in here by myself. But I just want to give you a quick little guide to periodic trends and explain how to do the alien periodic table if you missed the Zoom meeting yesterday. So we talked about a lot about the periodic table. The word periodic means repeating. And one of the things that repeats, if you watch the Hunting the Elements video, is the properties of the elements. There are 3 trends on the periodic table that we're going to cover today and explain how they change as you go around the periodic table. So I'm going to begin by drawing my crappy version of the periodic table. And we'll talk about 3 different trends. I got 3 different colors here to talk about 3 different trends. The first one is the easiest to understand. It's the atomic radius. If you remember from math class, radius is the difference from the center of a circle to the edge. So in an atom, it's going to be the distance from the nucleus to the farthest away electron. Another way to think about it is how big the atom is. Okay, so the farther an electron is, the greater its energy. So we have to think about energy levels. If you remember back to electron configuration, energy levels are what period you are on the periodic table or what row you are on the periodic table. So 7 energy levels. Each step down the periodic table means the electrons are farther away from the center. So atoms are going to get bigger as you go down the periodic table. That's a pretty common sense thing. The numbers get bigger, the atoms get bigger, the electrons are farther away. What's a little bit different is from left to right and right to left. So if you look at a periodic table, the numbers go up as you go from left to right. But that's a mass or a proton. Proton is the atomic number, mass is the red number, the number on the bottom of the periodic table. Now, those numbers go up, but all of the mass and all of the protons are in the nucleus. And the nucleus is really, really small compared to the size of the atom. So it actually doesn't change the size of the atom, even though you have more stuff in the middle. What you are getting, though, is a whole bunch more protons, which are positive, and a whole bunch more electrons, which are negative. Positives and negatives attract one another. And so as you add protons going from left to right and add electrons going from left to right, you're not adding energy levels, but you're getting more attraction, so the atoms actually get smaller. So you actually get bigger as you go from right to left. So for our purposes, the largest atom on the whole periodic table is francium. All the way at the bottom and all the way on the left. The smallest would be helium, all the way at the top and all the way up on the right. Size gets bigger as you go down and to the left of the periodic table. Okay. Next thing we're going to talk about is electronegativity. Actually, before we do electronegativity, let's do ionization energy. Ionization energy is the energy it takes to steal an electron, the energy it takes to remove an electron from an atom. So the first thing this has to do with is whether or not an atom wants you to take an electron. So if you remember from yesterday, all the way to the left, your valence electrons are like 1 and 2. These guys want to get rid of their electrons. Whereas to the right, 7 and 8, these guys are already close to or meeting the octet rule. They do not want to get rid of their electrons. So as you go from left to right on the periodic table, your ionization energy goes up. It takes more energy as you go from left to right. Now we also have to think about what's holding those electrons in, the nucleus. As you have more positive things, you're going to hold those electrons a little bit tighter. Well, excuse me. As you get more, the protons hold the electrons in, and as the electrons get farther away, it's easier to pull them away from the nucleus. So ionization energy increases as you go from left to right, but it also increases as you go up because the electrons are closer to the nucleus, and it's harder to pull those electrons away from that positive charge. So the highest ionization energy on the whole periodic table is helium. Helium, you are not going to get an electron from. Helium, the reason you give kids helium balloons is because they're safe. They're not going to change. They're not going to give away their electrons. They're not going to explode. They're not going to react. okay? The lowest ionization energy will be the complete opposite of that. It will be francium, because francium has one valence electron way far away from the nucleus. Super easy to grab that valence electron from francium. The last trend is electronegativity. Electronegativity is the tendency of an atom to want to get an electron. I say that this is Mr. Steal Your Electron. This is the tendency of an atom to want to attract an electron to itself. So if you remember the octet rule, everybody wants 8. So if you are close to 8, but not quite there, you really, really want an electron. So group 17, fluorine, chlorine, bromine, iodine, they're called the halogens. They really want to steal electrons, and they have the highest electronegativity. So electronegativity will actually increase as you go from left to right as well, except for group 18, the noble gases, because those guys already have 18, they don't want your electron, they have their own. So the highest electronegativity, same as with the helium thing here, you're also going to increase your electronegativity as you go up because you're closer to that positive charge in the nucleus. So the highest electronegativity on the whole periodic table is fluorine. Fluorine will absolutely positively steal your electron. Fluorine steals your electron more than any other atom on the entire periodic table. So now the reason I set it up like this is because there's a lot of information up here, but you only really have to remember 3 things. Francium's the biggest, because it's an entire country, large, francium. It's the largest atom on the whole periodic table. Helium, you're not going to steal an electron from helium. It has the highest ionization energy. It holds onto its electron stronger than any other atom. And fluorine will straight up steal your electron, will rip the electron from your cells, will do everything it needs to do. So there's your trends. I want to check out real quick your instructions. A lot of people were having trouble with the alien periodic table assignment. I want to make sure everybody knew how to work it. So if you go to modules, look at this week. Yesterday's assignment, alien periodic table. Click on that. Then you're going to click on this, make a copy of it, and change the name to your name. So click on it right here on the 3 dots. After it loads, click there, make a copy, and it will say copy of alien periodic table. Just change it to your name. I'm going to change it to tire. And then once it loads, you'll be able to move stuff around and then share it with me when you're done. And so what you want to do, if you go back to the instructions here, across left to right, something's increasing. Across left to right, something stays the same. Down, something's increasing. And down, something stays the same. So if you look at this, these aliens, these little crazy things, have a bunch of different things that can be different. They have the shape of their body, number of eyes, different things going on with the hair, different numbers of fingers. And you want to just rearrange them so that something stays the same going across and something changes going across. So let's look at let's make it adding a little hair thing from left to right. There we go. So my hairs increased as we went from left to right, and eyes stayed the same. So you want to keep rearranging that in different ways to make it all, and I think there's one short, you can predict what's left out. There's no right or wrong answer. There's just your creativity with how to do this. So have some fun with it, answer the questions, get it turned back in, and get you a nice little grade. Have a great day. Don't hesitate to let me know if you have any questions at all going forward.